In this question here, we're trying to find the unknown side, side x, in this three-dimensional drawing on a two-dimensional space. So let's zoom in and take a look. So we have two triangles here. I'm not going to label them, I'm just going to trace them out because it is a bit cut off. So I have this one here, and it has an angle here at the bottom of 30 degrees, and that broken line is going to be its height. Get a thinner marker, and we can assume that it is a right angle triangle. Okay, and same with this one here. These are right angle triangles. And the other one has an angle at the bottom here of 42 degrees. I'm going to trace it out here. And that's all the information we have. Okay, so the question is to find the value of x, which is this side of this triangle. And what I'm going to do is kind of, connect the information from one side here to the other side. Because if you notice, all the given information other than the 42 degrees is on my left-hand side. And if I wanted to solve the triangle on the right-hand side, I'd need at least the height. Okay, it's not enough just to have that angle 42. So I'm going to start by setting up my equation. Notice how I have my angle, I have a height, opposite side, and I have a hypotenuse. And I can just set up a basic sine. Let me do that over here. So I'm going to have sine of 30 degrees equals opposite over hypotenuse. And if I rearrange, I get height equals 22 times sine of 30 degrees, which I'm going to have to pull up my calculator for this. Let's bring it over here. And let's do 30 of sine, which is 0.5. You should know that from your special triangle, times 22, which is 11. And that gives me 11. Let me just take that horizontal line off. Great. So I have a height of 11. So I'm going to cancel that out. Put 11 here, and now I'm in a good position to solve for x. I can use sine again, sine of 42 equals 11 over x, which is my hypotenuse. And if I rearrange for that, I get x equals 11 over sine 42 degrees, which, let me do the math here. So 11 divided by 42 sine equals 16.4, and that is centimeters. So there you have it. We're solving a question in a three-dimensional question drawn on a two-dimensional surface. I think the hardest part of something like this is to visualize it, see what it looks like. If this is hard for you to imagine, this triangle kind of jutting out of the page, I'd recommend that you literally cut them out, put them on your desk. Again, you can think of this as, the table that it sits on, and that way you can see how, the triangles are, I guess, protruding from the surfaces and connected to each other via this, common side H. Okay, again, 3D problems, it's usually the visualization, but again, those of you who are artists might have an easier time with this.